Hi and welcome. Thank you for tuning in today. Before we begin, I want you to question something you've trusted your entire life. Gravity. You think you understand it. Things fall down. Planets orbit. The moon pulls the tides. Simple. But what if I told you gravity might not be a force at all? What if the reason you're standing on the ground right now is because space itself is curved? In the next few minutes, we're going to break one of the most fundamental ideas in physics and rebuild it in a way that will completely change how you see the universe. And trust me, by the end of this video, you may never think about down the same way again. What if gravity isn't a force? Not an invisible pull, not a cosmic magnet. What if the reason you fall to the ground has nothing to do with something pulling you down, and everything to do with the shape of reality itself? Take a second and picture this. You're standing on Earth. You jump. For a brief moment, you're airborne. Then you come back down. We call that gravity. Simple. But why down? Why not sideways? Why not up? Why does everything fall the same way every time? Now, zoom out. The moon is falling toward Earth right now, constantly, but it keeps missing. That endless fall is what we call orbit. And the tides? Entire oceans rise and fall because of the moon's gravitational influence, from nearly 400,000 kilometers away. Stand on a beach. Feel the water moving around your feet. That motion is caused by something hanging silently in the sky. Here's the first thing I want you to really think about. If gravity feels weak enough for you to lift a phone, how can it move entire oceans? Something deeper is happening. Back in the 1600s, a man asked a question that changed everything. If an apple falls from a tree, is that the same phenomenon that keeps the moon in orbit? That man was Isaac Newton.
There must be a pull, something that draws it to the Earth itself, a force, constant, universal.
Newton proposed that every object with mass attracts every other object with mass. Earth pulls on you. You pull on Earth. The sun pulls on the planets. It was elegant, predictable, powerful. For over 200 years, Newton's explanation worked beautifully. It allowed us to predict planetary motion and understand falling objects with incredible accuracy. But it left one haunting question unanswered. How? How does Earth reach out and pull you? What carries that force across empty space? No one knew. Until the early 20th century, a patent clerk turned physicist looked at gravity and saw something radically different. Albert Einstein proposed an idea so strange it sounded absurd at first. Gravity isn't a force, it's geometry.
If mass tells space how to curve, and space tells mass how to move, yes, then this term must balance the whole. It fits.
Imagine a stretched rubber sheet. Place a heavy bowling ball in the center. The sheet sinks. Now, roll a marble across the surface. The marble curves inward, not because the bowling ball is pulling it, but because the surface itself is warped. Einstein said space and time are not separate things. They form a single fabric, spacetime. Mass bends that fabric. The sun bends it deeply. Earth bends it less. You bend it too, just a tiny amount. Planets don't orbit because they're being pulled by an invisible rope. They move along the curves in spacetime. You're not falling toward Earth because it's pulling you. You're following the straightest possible path through curved spacetime. Pause and let that settle in. What if down is not a direction, but a curve? So, what does this mean for us? Why don't we drift into space? Because Earth warps spacetime around it, and your natural motion carries you along that curve toward the planet's center. Why do planets circle the sun? Because the sun creates a deep well in spacetime, and the planets follow its contours. And black holes? They bend spacetime so severely that all paths lead inward. Even light cannot find a way out, not because something is pulling it back, but because every possible direction curves inward. And here's where it becomes even more mind-bending. Gravity affects time. Clocks tick slower in stronger gravitational fields. This isn't theory, it's measured reality. Satellites orbiting Earth experience time slightly differently than clocks on the surface. Without correcting for this effect, GPS would become wildly inaccurate. Imagine standing near an extremely massive object. To you, everything feels normal. But to someone far away, your time is running slower. Gravity shapes not just where you are, it shapes how time flows for you. Think about that. Now, let's push it further. Imagine gravity suddenly vanished, instantly. The Earth would stop orbiting the Sun and shoot off in a straight line. The Moon would drift away. The atmosphere would no longer be held in place. Oceans would rise into enormous floating spheres. You wouldn't gently float upward. You'd be caught in chaos. Gravity feels subtle, quiet, constant, but it is the architect of structure. Without gravity, gas would never collapse to form stars. Without stars, there would be no heavy elements, no carbon, no oxygen, no planets, no life, no you. Here's something worth sitting with. Gravity is the reason matter gathers instead of drifting forever apart. It is the reason complexity exists. Can we control gravity? Not yet. We can calculate it. We can use it for slingshot maneuvers in space missions. We can measure its effects with extraordinary precision. But bend space-time at will? That remains beyond us. If we ever could manipulate gravity, it would redefine civilization. Artificial gravity in space habitats, new forms of propulsion, possibly even ways to shorten cosmic distances. It sounds like science fiction, but so did curved space-time, until we measured it. So what is gravity? To Newton, it was a force of attraction. To Einstein, it is the curvature of space-time. Both descriptions work, in different ways. But maybe the deeper truth is this. Gravity is not just something that happens to us. It is the framework that allows the universe to build itself. Every atom in your body was forged in stars that formed because gravity pulled matter together. Gravity lit the first stars. Gravity sculpted galaxies. Gravity made planets possible. Gravity made you possible. Maybe we're not being pulled down at all. Maybe we are moving through a universe that curves around mass, and we simply follow its shape. And if space-time itself can bend, what else about reality is not what it seems? If you want to explore more ideas like this, the kind that reshape how you see the universe, subscribe. Because next, we're going even deeper. We're going to ask, what is space? And the answer might change everything.